In this video, what we're going to be learning to do is to multiply polynomials. We've already learned how to add and subtract them, so the next step obviously would be multiplying, and you would think dividing. But it turns out that dividing polynomials is a little more advanced than you're going to see in this class, so we're going to settle right now for just multiplying polynomials. And we're going to start with multiplying the simplest type of polynomial times the simplest type of polynomial. So we're going to take a monomial times a monomial. And as silly as it seems, I would like to start this out by emphasizing that addition and multiplication are different, which I know sounds like a statement worthy of the typical teenager, duh, but it's easy to get them confused in practice. And even though it's easy in your head to say, yeah, addition and multiplication are different things, it's again easy to get them confused with polynomials as a student just learning it. So what I'm going to do is I'm going to put in this first section here the addition problem. I'm going to just write down the answer to this. So 3x squared plus 4x squared is 7x squared. And I'm going to write down the answer to this, 3x squared times 4x squared. Notice that's the same problem, except I'm multiplying instead of adding. And the answer there is going to be 12x to the fourth. And so now what I want you to do is I want you to look at these, and I want you to tell me, what are the differences that you see? And once you've told me what those differences are, I want to know where you think this 4 comes from. How did I get that 4? Because the understanding of where this comes from is going to be what really is complicated in this and will likely get you confused. So now let's look at this in greater detail. With the addition, we're adding like terms. This is, you know how to do this. This is nothing new or exciting. It's 7x squared. The multiplication part, however, is a little more fuzzy. So what I want to do right here is I want to break down for you exactly what's going on with this right here. So first of all, let's talk about this 3x squared. And let's rewrite that with no exponents. So it's 3 times, because when these are written together, it just means times, right? So 3 times, and x squared just means x times x. And then I'm multiplying all that by 4x squared times 4, and then x squared is x times x. Now the neat thing about multiplication is that it's what's called commutative. It doesn't matter what order you multiply these in. So if I wanted to, I could rearrange these to be 3 times 4 times x times x times x times x. And if we do this, I know how to do 3 times 4, that's 12. Nothing's changed there. And I also know how to do x times x times x times x. If I'm multiplying something by itself 4 times, I can rewrite that as x to the fourth. So where this 4 came from is just adding how many x's I'm multiplying by. And it turns out I can do that by adding those exponents together. 2 plus 2 is 4. So even though it's multiplication, to find what that exponent is, I'm going to add. And that's where this gets different and tricky, and people get confused on this difference between addition and multiplication in polynomials. So let's get a rundown of rules for this. If you're multiplying monomials, so to multiply a monomial times another monomial, and this, I cannot stress enough, is a foundational skill. Without this skill, you will not be able to do anything else in this module. So here's what we do. We take the coefficients, multiply them. Find all like variables, so all your x's, all your y's, etc., and you add the exponents up, and that's the new exponent for that variable. If a variable does not have an exponent, you can think of there as being a 1. So for instance, if I just have the variable x, that's the same thing as x to the first power. And armed with that, we can now apply those steps and multiply monomials to our heart's content. And after a while, this will get pretty quick and easy. So I'm going to do it 2 ways. I'm going to do it the quick way and then the long way so that you can see where the quick way comes from. So the quick way will always be on this side, and the long way will always be on this side, so I won't always write those up there. So for the quick way, what I do is I multiply the coefficients of our two monomials. 4 times 2 is 8. Then I take the variables. I just have one variable there, v, and I take 3 plus 2 is going to be 5. So when I multiply these variables, I do so by adding their exponents, and the answer is 8v to the 5th. Easy as that. Now the long way, to make sure that you know where this comes from. 4v cubed times 2v squared is the same thing as 4 times v 3 times 2 times v 2 times. And now I can just rearrange this to 4 times 2 and then times v 5 times. 4 times 2 is 8. V multiplied by itself 5 times is 8. V to the 5th. So if you can understand that this is where that's coming from, it makes it very easy to remember how I find that number. Let's try another one. Simplify the expression n squared times 7n. So again, I'm going to go quick way over here. That was a terrible cue, I apologize. Quick way over here, long way over here. So the quick way, I multiply the coefficients. There is no coefficient there, so I can think of there as being a 1. 1 times 7 is 7. Now I add the exponents. There's no exponent here, so I can imagine there being a 1. 2 plus 1 is 3. So this is 7n cubed when I multiply them. For the long way, if I'm taking n squared times 7n, n squared is n times n. Excuse me, got ahead of myself there. N squared is n times 7n is just 7 times n. And so I rearrange this, and I can see that it is 7n to the 3rd power. So hopefully you're seeing where this will get quick, and again, with plenty of practice, you'll get to where you can do this into your sleep really quickly. Don't try and shortcut it, though. Get good at it first, and then get fast at it. So example 3, now I have 3 items that I'm multiplying together, but it turns out it doesn't matter. I do it the same way. Multiply all the coefficients. 5 times 4 times 3. If you don't want to do that in your head, feel free to calculate it up using the calculator. But 5 times 4 is going to be 20. 20 times 3 is going to be 60. All the variables are the same. There's no exponent there, so I can make that a 1. 3 plus 1 plus 3 is 7. So this is 60 x to the 7th power. And then again, writing this out the now painfully long way, given how much there is here. 5 times x times x times x times 4 times x times 3 times x times x. X is everywhere. Oh my goodness. And so now I rewrite this. 5 times 4 times 3. And then I have x's coming out of my ears. 3, 4, 5, 6, and 7. 5 times 4 times 3. However you want to slice it up is 60. And then if I count all of these x's, there's 1, 2, 3, 4, 5, 6, 7 of them, x to the 7th power. So hopefully you can see that it's just this idea repeated over and over again, and you can do it very quickly by multiplying the coefficients, adding up the exponents. So now let's step it up a notch. Notice in all the previous problems, we've had one variable. In these, not so much. So again, just as before, I'm going to do it the quick way and the long way. For your notes, you do this however you see fit. So for the quick way, 8 times 7 is going to be 56. And now I have two variables, a and b. So I add up the exponents on all the a's first. 2 and 4. So 2 plus 4 would be 6. So I get a to the 6th. For the b's, this one has an exponent of 3, and this one has an exponent of 1, be very careful that 4 only applies to the A, does not apply to the B. So 3 plus 1 would be 4. And so my answer is 56, A to the 6th, B to the 4th. So I can only add those exponents when the variables are the same. Don't mix them up. Now if I want to look at that in the long way, I have 8 times A squared times B cubed, so that's 3 B's now. And then times 7 times B to the 1st, and then 4 A's. But again, multiplication is commutative. I can rearrange that as I please. So I have 1, 2, 3, 4, 5, 6 A's that I'm going to put there. 3, 4, 5, 6. 1, 2, 3, 4 B's. 2, 3, and 4. And just, again, simplifying it down, this is now 6 A's, A to the 6th, and 4 B's, B to the 4th. No matter how I slice it, it's going to come out that way. All right, example 5. Now we're getting somewhere. Find the area of the figures below. Area, if you will recall from, this is probably middle school geometry, if you'll recall, area is the way of describing all of the space contained on the inside of the figure. So we're asking how much stuff is on the inside. And for what's called a parallelogram, which both of these figures would be, this of course is going to be a square. This is a more classic look at a parallelogram. But for anything of this nature, the area is going to be the base times the height. So the base and the height have to be perpendicular to each other, that is 90-degree angles, which will be designated by this little square. And so if you see that little square, if you multiply one side of that by the other side of that for a parallelogram, a four-sided figure like these, then you'll be able to find the area. So in this case, to find the area, it's base times height, and it doesn't matter which one you call which, as long as they're perpendicular to each other. As represented by this little square, it'll work out. So in this case, the area is going to be 3x times 3x. Notice I'm multiplying as opposed to finding perimeter where I added. And so my area is going to be 3 times 3 is 9. X to the first times x to the first, 1 plus 1 is 2. So my area is 9x squared. Over here I do the same thing. Remember, base and height have to be perpendicular to each other. So you're looking for that square, which you see right there. So in this case, I'm going to use x as my base, 2x as my height, and so my area is just 1 times 2, and then these are both x to the first. 1 plus 1 would be 2. So area is just one of those practical applications where it requires multiplying. So if our base and height are polynomials, multiplying by polynomials, which is exactly what we're learning. Now we could also have this. You'll notice this thing is not a parallelogram. This is a different figure called a triangle. And so the area of a triangle is equal to 1/2 base times height. And remember, base and height have to be perpendicular. So in this case, when I go to multiply this, A is going to be 1/2 times my base, which I'll call 8 in this case. And it really doesn't matter which one you call which, it'll work out the same, times my height, which is 2x. And this is about as simple an example of multiplication as you can get with polynomials. 1/2 times 8. And by the way, if it's easier for your calculating, 1/2 is the same as 0.5. So if you like that better, you can also use 0.5 base times height. 1/2, 0.5, what have you, whichever one you want, times 8 is going to be 4. And 4 times 2x, we multiply the coefficients. 8, there's only one variable, so this is 8x for the area. So remember, if you're asked for area, there's really only two cases I'm going to give you. A triangle, in which case it's 1/2 base times height, or I could give you a parallelogram, in which case the area is base times height. One final example that doesn't look like multiplication, but it is. Remember the meaning of an exponent. This squared means we're multiplying that by itself that many times. So when you see 6x cubed squared, what that means is 6x cubed times 6x cubed. And you know how to do that. It's what we've been doing, multiplying monomials. 6 times 6 is 36. X raised to the 3 plus 3 would be 6. And there you go. Good luck, friends and neighbors.